Hello, everybody. My name is Fraser Cain, and I am the publisher of Universe Today, and this is your virtual star party for October 28th. I guess this is the spooky Halloween edition, 2012. Ooh. And we are scared by the horrible, horrible full moon that is blasting all of our dark skies away. So joining us this week, we've got some really cool astronomers. We've got our good friend Gary Gonella in Los Angeles. There
Hi.
he is. We've got Mike Chasin in the San Diego area.
Hi, everybody.
There he is. We got Roy Salisbury in the Las Vegas area. And we've got from the sort of peanut gallery side, we've got Scott Lewis down in the Los Angeles area, and Thad Szabo, Dr. Thad Szabo.
Good evening.
And we've got Stuart Foreman, who has been sort of opened up to this week's star party with this beautiful view of the Ring Nebula, and Stuart is in the San Francisco area. So again, this is a sort of West Coast-ish star party, and that is not a big surprise because Hurricane Sandy is currently ravaging the East Coast of North America. So it's not surprising that all of our East Coast friends are not able to join us tonight as they try to keep their houses from filling up with water. So it's it's a big storm over on the East Coast. And also to everybody who wondered if I'm safe, thank you for your well wishing. We had a 7.7 magnitude earthquake happen just a few hundred kilometers from where I live on Haida Gwaii here on the west coast of British Columbia, which is a really big earthquake. It's the second largest earthquake that's happened in the last 60 years in Canada.
What did it feel like when you were there?
Didn't even feel it. I did not even feel it, which was pretty funny.
Earth's just going crazy.
They're getting ready for December 2012, right? That's what's going on.
Oh yeah.
No.
Well, apparently this last one was this earthquake that we just had. It was one of the slip fault ones. So the two faults sort of slid beside each other, and so that doesn't generate a tsunami, fortunately. But in the past, parts of the British Columbia coast have also been devastated by tsunami. So it's a real risk. We actually have tsunami warning signs and sirens that could go off, and we all have to head for high ground if there's a problem. So there you go. All right, well, let's get rolling. So for anyone who's never done this before, what this is our virtual star party where we have a team of astronomers. Tonight we have four astronomers who are broadcasting views from their telescopes live. So what you're seeing right now is a live view, for better or for worse, of what they're seeing. Now, we're really fortunate that on the West Coast, actually, the seeing is really nice. We're getting some of the best views that we've had in quite a while, even though we've got a full moon, which is really sort of destroying a lot of the dark skies. So we'll see. I think it should be a good night. Now we'll sort of see whatever objects we can in sort of this time of the year, but we'll also take requests. So if there's some object that you want to see that you kind of know by its M or NGC number, we'll try and bring it up as well. And we'll also answer any questions you have about space and astronomy, about amateur astronomy, astrophotography, anything like that. Now, if you want to ask any questions, there's a bunch of places you can do that. You can go to YouTube, and you can post your question over on YouTube. You can post your question on the event page where we sort of initially announced this the show. You can also, if you're watching this on Google+, you can do that. You can post a question there, or if you're watching this, somewhere embedded out on the internet, or you just like Twitter, just use the hashtag StarParty, and we'll get it from there. Cool. All right. Well, let's get rolling. So I guess first up, as I mentioned, we've got the Ring Nebula, aka M57, which is easily my favorite object, and this is from Stuart, and I think this is a really good version, Stuart. Like, you're really nailing the Ring Nebula.
Thanks. What I did today was, because the moon, the moon is out. Well, sun's still out too, but the
moon right now. People should understand the moon is as bright as the sun right now.
Right. It's pretty
really
bright.
horrible.
I did a short exposure time, but I pumped up the ISO on this, so I'm actually pretty pleased with this. I think this is a 60-second exposure.
Now, when
That
you say
looks
pump
great.
up the ISO, where have you pumped the ISO to? And if people maybe don't understand what the ISO is.
Yeah, I'm using a program called Backyard EOS, which controls my camera, and I'm using a Canon T1i, which is one of the Canon Rebel series, and you can control the shutter speed and the sensitivity of the camera, and the ISO is just the sensitivity of the chip. And when you turn up the ISO, you're turning up the gain in the chip to make it more sensitive to light. So an ISO of 1600 is twice as sensitive as an ISO of 800, but you can't. But it's the amount of light that each pixel will take is less because the gain is turned up high.
So it gets pretty noisy, right? Is the problem?
Exactly.
The downside, yeah.
Exactly. But the Canons are nice because they're relatively low noise cameras.
I didn't know you were observing with Nicole. That's really awesome.
The noisy astronomer.
Not noisy.
I mean, those Canon. I think people should really understand. I mean, if you've got a fairly, if you've got a good telescope and it's got reasonably good tracking, those Canon cameras make just fantastic. CCDs. I mean, they're a great way to collect light, and an old T1 is not that expensive for just a body. I mean, you're only looking at probably a couple $100 on Craigslist or eBay.
It's a great way to get started.
Yeah, totally. I mean, I use a T3, and it's just fantastic. So
It'd have to be one of the DSLRs, though, because you want 16-bit processing. I've got an old Canon point-and-shoot, and I've hacked it using the Canon Hackers Development Kit to get better time-lapse exposures and be able to take raw images with it, but it's still only 8-bit, meaning that it's only sensitive to 256 levels of light instead of the 65,000 different levels of light that you get with a 16-bit camera.
Yeah, just to geek out on you a little bit, the Canons, at least the T1 series or the T2, those are 14-bit, but your point is still made.
All right, and then I think we'll move on. So I'm going to just show you. So this is Roy's view of the moon. And
yes, and this is actually done with the T1 as well.
That's done with the T1 too, yeah. Your moon is upside down, Roy.
Yep. Just letting you know, if you're going if you're watching this outside with your laptop and you look at the moon, unless you're in the southern hemisphere, this is not what it looks like to you right now.
Yeah,
the big impact crater here should be in the lower left.
That's right.
Correct.
Yeah.
Yes.
And for those who were watching last week, you can actually see the Apollo 11 landing site. It just happens to be on the wrong side. So, and actually, you know what? This is a time for some absolutely shameless self-promotion, which is I was going to show people. We've updated our Phases of the Moon app.
Woohoo!
So, yeah, cool, eh? And so you see, it's got. You can spin the phases of the moon, and you can see. And so, as you can see today. Horrible full moon. So we've got the phases of the moon on both Android and iOS. I'm really excited. We just released it. And we actually just submitted the iPad version of it as well. So
Nice.
yeah, I'm really excited. It's going really well. Okay, you can pick that up on the Google Play Store or on the iTunes Store for only 99 cents. All right, let's move on.
Tell me how awesome it is, Fraser. How awesome is your app?
It's super awesome.
It is. It really is awesome.
We got a 4.9 average rating on the Android store. We're the highest rated moon app. So
I show it to my students in our planetary astronomy class, and they're like, "I can get this? Absolutely."
Absolutely.
But
all right.
it's a really great tool for it. So.
All right, that's enough, Scott. That's enough.
I'll take the check later on. Yeah.
All right, let's move on. So Gary, let's move on to what Gary's got. And someone I think actually asked for this. Oh, and somebody asked for Jupiter this week. And unfortunately, because our East Coast astronomers are offline, Jupiter doesn't rise until about 10:30, 11 West Coast, or in your local time. And so, unfortunately, we're not going to be able to have Jupiter tonight, which is really too bad. But within another month or so, month and a half, then we'll have Jupiter on the West Coast during the star party as well. So then we'll be able to definitely show it. Right. So, Gary, what have you got here?
This is Andromeda M32. This is a heavily requested one. It's the closest galaxy to us, along with its two companions, M31 and 110. Chad? Thad?
110 and 31.
M31 is the main galaxy for Andromeda, the one with the 200 billion to 400 billion stars. And then M32 is the one that looks like a little ball off to the right in the field of view there. And M110 is the fuzzier patch, more diffuse patch up in the upper left corner. So dwarf galaxies, but still tens of millions of stars in both of those dwarf galaxies that are orbiting Andromeda there. So one question I often get from students, I mean, it's really hard to see any kind of spiral structure in Andromeda using visible light. It shows up better in ultraviolet. But one way that you can tell that this is a spiral galaxy is it does have dust lanes that are visible in the other type of galaxies, which are ellipticals. And both of the dwarf galaxies in the field of view here are elliptical galaxies. Dwarf galaxies don't have that gas and dust that are present that are making those lanes that we can see kind of cutting along the edge of the galaxy there. Those are only present in spiral galaxies like Andromeda.
And look at, I don't know if this is coming through for the people watching this, but you can, it's a really good night for Andromeda tonight. You can see these, are they like knots of star clusters?
Yes.
Yeah, what's going on there?
So just places where you have more rapid star formation. One other way that you can tell it's a spiral galaxy is that your older, well, sorry, not your older galaxies, your elliptical galaxies don't really have new star formation. So they tend to be only older, generally redder, maybe a little bit yellow stars. But in a galaxy like Andromeda, which has new star formation going on, it will occur in clusters, just like we have here in the Milky Way. Like, for instance, if you can see the Pleiades tonight, the Pleiades is a new star cluster. And so when that happens, you get a lot of very bright blue, very hot young stars. And coming together in groups like that, they're visible even from, across 2.5 million light years in another galaxy, like in this picture of Andromeda here from Gary.
And Andromeda is really cool. I mean, it's one of these objects that you can actually see with the unaided eye. On a, if you got really dark skies, if you can see the Milky Way, you can probably see Andromeda as well, just with your own eyeballs. And it's, I used to do this thing. You sort of do this looking for fuzzy objects in the sky. I don't know if you guys ever used to do this too. You would just kind of, on a really dark night, you go outside and just look up and look for something that's kind of fuzzy, and then look at a star chart afterwards to figure out what it is that you saw. And I actually rediscovered a whole bunch of Messier objects just with my own eyes. I was able to find Andromeda, and I'm trying to remember what else I found. Pleiades, things like that. And I found Dr. Phil Plate. Yay!
Hello.
Dr. Phil.
Testing.
You're still there.
We can hear you.
We got you.
Wow.
I don't know. You're on a funny microphone. You might want to check which microphone you're using.
Yeah, doing that now.
Okay.
And Fraser, just for the record, this is a 2-minute exposure with a hydrogen alpha filter, if anybody cares.
I care, Gary.
Okay.
I really.
Thank you.
Gary, that's an H alpha filter image of M31?
Yeah, 2-minute.
Huh.
I'm going to move on. So for anyone who doesn't know, Phil Plate is the AKA the bad astronomer.
And my cat.
And his cat, the bad cat. And this is great, Phil. It's been like months and months since you've joined us for one of the virtual star parties.
Every time you have one of these things, we have people over or I'm traveling. This time I just got a new computer, and so it seems to have worked actually fairly well. So, yeah.
Okay. You just had to go through reinstalling all of the drivers and so on. So, well, let's move on. So, Mike, what have we got here? And
that is the Veil Nebula. This, like Gary is doing, is also shot in hydrogen alpha. This is about a 2-minute exposure. To give you a sense of scale, if we can talk star magnitudes, the bright star right in the middle there is about a 4th magnitude star. So depending on your skies, you might or might not be able to make this out. I believe this is, correct me if I'm wrong, we're in the constellation Cygnus here.
Yep.
So we're fairly close to right overhead, maybe a little bit west if you're looking up. And Thad, feel free to chime in here. But as I understand it, this is a wispy part of a star that went supernova, that went kaboom thousands of years ago. And because my field of view is not big but not small, but just that Goldilocks in between size, I can get a part of that cloud of gas from the exploded star. So that's kind of what you're looking at there, is this wispy edge of a bubble.
Yeah, this looks like the western part of the veil here. This was featured on APOD maybe about a month or or 6 weeks ago or so. But the thing is, yeah, if you could get a larger field of view, you would see this defines an arc that, not a complete circle, but you can definitely see the outline of most of a circle if you follow where the nebulosity is here. Although tonight, yeah, you'd have a heck of a time picking it up with the full moon not too far away in the sky. So nice job pulling it out, though. Nice job pulling it out.
And it looks like you're getting some kind of light artifact. If people are wondering, that big sort of circle. Yeah.
I think my guess is that is an internal reflection. I'm working off of. Let's see here. Like I said, this is about a 2-minute exposure, and I'm binning it times 4. So that makes those pixels on there really, really sensitive. So it makes them, in effect, 4 times larger, or I guess 16 times larger, since they're 4 by 4. So they're going to pick up a little bit more of the artifacts or the defects within the refractor telescope. When I shoot this at a bin times 1, I'll get like a 10-minute exposure, and I'll see that same effect, but it's much, much smaller, just a slight halo around the star.
And I think this is great. So Roy, you just posted. I think this is a photograph that you posted.
Yeah,
showing the whole structure.
Yeah, this last week, or after last week's star party, we was talking about this, how big the whole structure was. So I decided to try my hand for the very first time at doing a mosaic. So this is supposed to be a 9-pane mosaic, but you can see I'm missing one of the panes there. I forgot to put it in the
What
stack.
a pain, right?
But I can see that bright star.
Done it, but it's all of the complex is there.
Yeah, and I can see that bright star over on the right-hand side.
Right.
And so this is
Came
what
out really
Mike
nice.
is picking up. Yeah.
Yeah, that's really well done.
That's fantastic.
So I mean, you can kind of get the feel. I mean, there was a central object here, which and Phil, you could probably help me out on this, is known to be a neutron star at this point. Have we found a central object here for the Veil?
Oh, golly, I don't know. I'd have to look that up.
Okay.
But I can very quickly. I know a little bit about this. I've seen this, actually, back when I lived in California with an 18-inch telescope with an O3 filter. And an O3 filter lets through a very specific color of light that's given off by oxygen. And there's a lot of oxygen in these supernova remnants, and that particular flavor of oxygen is a very strong emitter. So you're really sort of picking out the brightest light. And with a big telescope, I could see it. I mean, just looking through the eyepiece, there was that thing on the sky. It was phenomenal. It was probably the coolest thing I've ever seen through a telescope.
And this is cool. So I'm going to go to Stuart's Blue Moon right now.
And it's blue because I have a light pollution filter over the lens, over the chip of the DSLR, and the DSLR itself is modified. So the color balance will be off on this. I could have adjusted it in Photoshop, I didn't bother. But what we're looking at here is, I believe this is Tycho crater.
The big one.
Yeah, the big one.
The one that really stands out.
Right.
So, yep, and you can see, I mean, these white streaks coming away from it. So you can imagine when whatever asteroid hit the moon plows into the moon, that you're going to have debris flying out away from it, and so it leaves these trails along the moon. Looking with binoculars, you can easily see they stretch, more than halfway around the moon. These rays that are coming out of Tycho crater. So it's one of the things that it definitely draws the eye to it. I mean, your eyes drawn to follow along the lines that are projected from this crater and kind of drawing you back to it, wherever you look along the full moon here. So.
Now, is it a newer crater? I mean, it's got to be one of the newer ones, right? Because it's got these bright rays and.
Yeah, I'm not sure of the age here. I mean, there's nothing. The only thing that would degrade rays would be exposure to radiation. Right. And there's definitely brighter ones. I know like Proclus and Aristarchus definitely show up much brighter than this. But yeah, not sure of the age.
Oh, Stuart, we got a request for a binary. So I know you've got a few binaries you like.
Yeah, I've got a couple in my queue. I can put it up right now if you want. But
that would be great. Yeah.
Okay.
While he's doing that, I'll say that when you asked if there's a neutron star in the Veil, and as soon as you asked that, I thought, I don't know, and that's something I would know. It's just something you read a lot and you stumble on that stuff, and I just looked it up, and it's actually looking around. I'm not seeing any references to either a black hole or a neutron star, And then I realized, oh, how old is this nebula? And it's at least 5,000 years old. So I'm guessing that if there is something in the middle, it's cooled off maybe, and it may not have been seen. I'd have to go searching the professional journals, I think.
I mean, what would it have had to have been? Like a Wolf-Rayet star to detonate like that, or?
Well, it's just a supernova. It could have been anything. Just a massive star. So it could have left a neutron star or a black hole.
That's true. Or if it was a Type 1A, then it would have. It could have
blown
like
itself apart. That's possible.
Yeah.
I'll keep looking. I just wanted to jump in and say that.
And so, of your binary star candidates, which one did you choose?
This one is Albireo. Color will be just a little off because of the filters I mentioned before, but I like this one because you see a blue and you see a gold, and it's a really pretty binary that's really easy to find with small telescope.
Actually, Scott, I don't know if you've got Stellarium going. Where would we find Albireo?
Let's go ahead and find it here.
So for those who don't know, Scott's using a piece of software called Stellarium, and it's free, works on Linux, works on PC, works on Mac, and it's awesome.
It is awesome.
iPad and so on, yeah.
So over here we have Vulpecula, and we have Cygnus and Lyra, and it's pretty much just right here on the border between all of them. And as I zoom on in here with this awesome software, you can actually see it resolve into the two separate here for Beta, to Cygnus and Albireo.
Yeah.
So, a couple of good ways to find it in the sky. I mean, it's roughly halfway between Vega and Altair, so the western edge of the Summer Triangle. It's almost smack in the middle between those two bright stars, and it's not terribly bright. I know I have trouble picking it up here from all the light pollution in LA. The other way to get to it is Deneb, the other bright star in the Summer Triangle. You follow back through the center of either the Northern Cross or Cygnus the Swan, however you prefer to look at it, and follow in that direction to again point roughly halfway between Altair and Vega, and there's Albireo.
Yeah, it's the bottom of the Northern Cross.
Yeah.
Or the head of the Swan.
and right in it really kind of feels like it's the very middle of the Summer Triangle. So very cool. Okay, cool. Well, let's move on. One last look at Albireo before it gets replaced. That's a beautiful object. And so you can. What does it take to resolve that into this binary? Like, will a pair of binoculars do it?
No, you'd need a scope, but it can be a small scope to do it. Binoculars, you'd have a little tough time.
I've done it with 25 by 100 binoculars. So, yeah, a scope at any magnification 20 or higher would be able to split the pair.
So. All right. I'm going to move to what Gary's got.
Okay, this is the Cave Nebula in Cepheus.
Oh,
and
nice.
I'll let somebody who knows what they're talking about describe it.
You found it. You discovered it.
It's this big thing in the sky, and if you look real close, you can see a bear hibernating in the bottom of it.
It does look like a bear.
It would be time of year for that bear to crawl in there, right? So.
Yeah.
But I mean, this is an emission nebula, and we're shooting with H alpha, right, Gary?
Correct. 2-minute H
Yes.
alpha.
So anything that he's going to be able to see is hydrogen gas that has some energy source nearby that's knocked electrons off, and as the electrons recombine, they drop down in energy level. As the electrons recombine with the protons, they drop down in energy level, then give off several wavelengths of light, but the strongest one is this red wavelength. Of course, you're saying, wait, that's black and white. Why are you telling me it's red? Well, if it was in color, you would see that this is a red colored light, indicating where you have the most recombination of electrons with protons in the hydrogen that's there. We also get some dark protrusions in there, so there's some colder molecular clouds kind of blocking the view of the hotter gas that again is being pumped up with energy from a very hot star that's in the region. And so it's these colder regions that could potentially collapse to form stars. We'd need a little push from a supernova that might go off in the region. But if you have a star that's big enough and bright enough to jazz up the hydrogen and get it to glow like this, that star is also big enough to go supernova. So
And
It's
we
a
just got a
technical
request.
term, you
Somebody
jazz.
wanted to see Betelgeuse, which is in Orion, and unfortunately, Orion still won't rise until probably midnight-ish right now. So we're still a couple of months away from being able to show off Orion in the Star Party. But don't worry, boy, when it shows up, it's all we'll be showing. It'll be Orion.
And then everyone will get
Orion.
bored with it until
Yeah,
we
you'll
can't see it
get totally
again.
bored. It'll be Horsehead Nebula, Trifid, Rosette, lame. So yeah. So don't worry. Bide your time. Like
Lame. I thought the Rosette was your favorite.
It is my favorite. It is.
Everything's his favorite, though.
Yeah, everything is my favorite.
Except
love
for
this.
green moons.
I love
or
that
pink
too.
suns.
Yeah.
Pink suns and green moons are not Fraser's cup of tea.
So I like the colors to be natural. No, I want to remind people that if you want to be notified when the virtual Star Party happens, what happens every Sunday night when it gets dark on the West Coast, and it's getting darker and darker on the West Coast now. As the nights are getting shorter, and so we're probably going to be starting tonight. We start at 7:30. Next week we'll probably be able to start at 7. However, it is daylight savings time next week, and so we'll actually be able to start an hour earlier. So I think we're going to start at 6 p.m. Pacific Standard Time next week, and so that'll be 9 o'clock Eastern Time, which is great because during the summer, the poor people in the Eastern Time Zone who have to stay up till 1 in the morning to watch this will get a break. So you'll get it right at your prime time. So you have to choose between us and The Walking Dead. I choose us. PVR, The Walking Dead. All right. So right, let's move on. So what do we got with Mike?
What we are looking at here is a very, very faint picture of M33, the Triangulum Galaxy, again through hydrogen alpha. What's interesting about this one, or at least what I think is interesting, is when you see the beautiful colors of images of it, it has a nice blue shape and a nice white core, is that you see these beautiful pinkish, reddish spots in the outer limbs. And if you can use your imagination and see some of the brighter spots in this faint spiral shot in hydrogen alpha, that accentuates these star-forming areas. So you can just make out in the outer edges, if you can see a spiral, twisted-shaped galaxy in the middle here, you can see the faint outline of a galaxy in its arms, and then you can see those areas where the star formation is occurring. If you can see the galaxy at the center, probably at the 9 o'clock position, there's a pretty big one there. I don't know if someone has a color shot they could put up at the same time, but that would allow folks, if someone could grab one quick, you can bounce between the two and see the effect this filter adds.
So that
so Scott's got a good view of the sort of the simulation of it here in Stellarium.
Okay, perfect, and that's almost oriented the same way, I think, there.
That emission nebula that's off at 9 o'clock, that's again one of these hydrogen alpha regions, huge star-forming region, much bigger than the Orion Nebula would be in our own galaxy. This is comparable more, if I remember correctly, to like the Tarantula Nebula in the Large Magellanic Cloud. So if the Orion Nebula is roughly about 1,500 light years from us, so if you were a being living in the Triangulum Galaxy and you could see that nebula that's off to the right, if you were 1,500 light years from it would dominate the night sky. That region would just be filled with bright stars, and you could even kind of see the glow of the gas even with the naked eye, if you were 3 million light years away in the Triangulum Galaxy to get that view.
With CCD cameras for eyes.
No, actually...
Go ahead.
Honestly, you can, if you're in a dark enough place, you can pick up the Orion Nebula with the naked eye, and this is something that would you wouldn't get red. That's one thing I should say. Yeah, with the way the human vision is structured with the cones, it still wouldn't look red, but you would definitely be able to see the gas present from the distance that the Orion Nebula is from us. If you were that distance from that little blob, is called NGC 604.
Right, that's what I was going to jump in and say. It's actually one of my very favorite Hubble images, and it was very early on, and in fact, I kind of wish they'd revisit it, get a higher resolution, deeper image, because it's kind of grainy. But if you look up NGC 604 on Google, you will see stunning pictures of that in high detail, and it's a huge star-forming complex. There are lots and lots of stars in there.
Very cool.
And Fraser, I'm also on M33.
Oh, are you? Oh, great. Okay. Well, I'm going to go back so we can compare and contrast. So you can see what's really interesting about this. So I'm going to sort of show you. So this is Gary's view. in hydrogen alpha, and you can see that Gary has a much wider field of view. And then I'm going to switch to Mike's view, which is a lot more sort of, I guess, zoomed in, but a sort of smaller field of view, so you can kind of see the difference. And I think
I did see a few comments on how it looks kind of washed out, and if you look over here on still air, it's because the moon's right there. So
on mine, this light area over here and the light area in the two corners is I'm real close to the moon.
Yeah, so I think people should really see that. So if you can see that over on the right-hand side of Gary's image here, you can see how the moon is washing this out, and so this is a very dangerous place to go and try and observe anything. And I think Roy is getting yeah.
I think I measured it in the sky tonight, the Sky X, and it was about 18 degrees away from the moon. So that's about your outstretched hand. So imagine if we were shooting into a car's headlight, we're one hand's width away from it. So not that I'm getting defensive, if I'm not.
No, it is a
no. Mike, it's great.
I was just in the Rocky Mountains at a dark site, and I could see it with my binoculars. I have big binoculars, but it was an easy. You couldn't see it naked eye, but it was easy with binoculars, and that was with no moon. So when the sky's dark, this is not a hard object, but it's hard to see any shape to it. It just looks like a little fuzzy thing.
Yeah, and we had it I think 2 weeks ago, and it was you could really see the shape and the structure. So I am not gonna give the guys a hard time this week for getting completely washed out by the.
And Mike, we can see great detail in our hangout, but when it goes to broadcast, they lose
drops a lot. Okay.
Yeah.
So I can see it great.
Well,
Sorry,
thank you.
All you viewers out there, but we have the best show.
You did a good job, Mike. You did a good job.
I feel very validated now. Thank you. I'm set. One interesting point about it, in looking at that versus Roy's too, is it shows the difference how, with a wider field of view, how much more light you capture and how it makes those things brighter. So particularly, I hear and I see that question when you're getting into astrophotography, do I want to use the 10-inch light cannon, or do you want to use a smaller telescope? And boy, it's a lot easier, I think, to get good results at first with a wider field of view. Things just tend to pop more.
So I've switched to Roy's view now, and I think is this the Wizard Nebula?
Yeah, this is the Wizard NGC 7380.
And same problem, right? I mean, I can see the moon is starting to wash out your view too.
This is through hydrogen alpha. It's just have to go so long to get anything, even with the hydrogen alpha right now, for whatever reason. I mean, it should be blocking out all this moonlight, but it's damn bright out.
Yeah. Okay, we all need to stop complaining about the moon. We need to get over this, right?
It's not the moon's fault. It's just reflecting light from the sun.
Yeah.
What's the proper name of this one? The catalog number?
7380.
7380.
Oh, okay. I don't really know it that well.
I'm going to move over to Stuart Scott because I see a double-double. That's a Tim Hortons, it's a Canadian thing.
Yeah,
it's in and out in California.
Yeah, it's in and out, yeah.
Yeah, it's one of the few things that can resolve well in the sky. But I like it because it's obviously a double-double. It's two double stars. But if you're to look at it in a small scope under low magnification, you would just look like one double star. But if you punch up the magnification higher, say if you looked at it under like 15 or 20x, it would just look like a double star. But if you look at it under like 120x or 200x, you can see that each star resolves into its own double.
Yeah, and I think we had Pamela schooled us last week or 2 weeks ago that they indeed are like actual binary systems.
Yes.
Right.
Yeah, unlike Albireo, which is a visual optical binary.
I think it's unclear with Albireo. I was just reading about it recently, and it's like, maybe, maybe not. If they were farther apart, it would be no, and if they were closer, it'd be yes. But they're right on the edge where they could be bound. So no, I don't think anybody's really sure. Which I think is pretty cool, actually.
Nobel Prize for somebody.
Yeah.
Fundamental.
I'll come by and we'll start working on that.
I don't think they don't give Nobels for a result where you go, oh.
I was on the edge about this, but now, great job, guys.
Oh yeah, I guess so. Sure. That's funny. All right, well I'm gonna move over. Mike's got us a. Oh, that's nice.
That's a good one.
Mike, what is this?
That is the double-double cluster. This is in the constellation Cassiopeia. Someone help me.
It's in Perseus, but
Perseus.
it's near the border
Okay.
between Perseus
It's on
and
the border,
Cassiopeia.
Okay.
Yeah.
So this is two open clusters of stars. I am being uncreative and just reading about Wikipedia about it because I didn't know much about it. But what's interesting, I think, is that there are two clusters. One is probably about 1,000 light years behind the other one. So there's a little bit of 3D depth to that. And what's interesting is they are headed towards Earth at the speed I am reading of 22 kilometers per second. So eventually they'll be here.
In a few trillion years. Right, so this is another one of those objects that I discovered. And by discovered, I mean that I was able to sort of see some fuzzy bit in the very dark skies where I grew up, and then was able to look that up in a catalog and discovered that somebody had already discovered, like Messier. Messier!
Only a couple hundred years, right?
A couple hundred years before me, yeah. But I think what's great about this is it's wonderful in binoculars. You know, if you've got a pair of binoculars and anybody can find Cassiopeia, right? It's that W. And if you can find Cassiopeia, then just below Cassiopeia is this double cluster where Perseus is like this spear that comes up underneath it, and you can absolutely spot it. So.
And even skies with moderate, well, I won't say moderate light pollution, but for instance, I had my students out at our dark sky site in the Santa Ana Mountains about 2 weeks ago. And you're barely able to pick this up with the naked eye from there, and that's kind of close to Irvine, California, and Santa Ana, California. So there's a good deal of light pollution. The Milky Way is barely visible from there, but again, this is a bright knot in the band of the Milky Way. So we're it's one of the things I can count on. It's like, okay, I want you to sketch dark sky objects. Okay, this one I can find this one. So yeah, but. Pretty clear. And if you get out somewhere away from light pollution, yeah, it jumps out of the sky at you.
Yeah, highly recommended. Roy, what have you got there? I see a globular cluster.
Yeah, that's M13. I was doing it through my DSLR, and with that pesky bright light up there, and it just didn't come out very well.
There's like some kind of checkerboard pattern going on it.
That checkerboard pattern is because it's a DSLR, and I switched it over to monochrome instead of color. So that's the little Bayer, whatever it is, that's in front of the CCD cameras.
But I think Stuart's got the same object, right?
I do, and I didn't turn off my barometric. So.
He's in color. Mine's in black and white.
Yeah.
He's in blue.
Yeah.
So I'm not.
Stuart's doing his
color
blue.
pixels.
This will be Stuart's blue decade.
Well, I'll take off my light pollution filter next week. It will be less blue.
So, Roy, are you binning here as well?
This one, I don't believe was.
Okay. So yeah, then
If
that's
if I had binned it, that's what I usually do when I do monochrome. I'll bin it 2x2 so I don't get that checkerboard.
Yeah.
Actually, Lim, can I ask a
cluster.
technical question to DSLR users? If I did a custom white balance with this filter in, would this work? Would it work if I used a gray card and just shot a custom white balance?
It should.
Okay, I'll try that. I'll try that before next week.
It's very difficult to create those custom white balances.
I have a gray card that I can use.
Oh.
So we would lose this blue hue?
Well, you keep complaining about it.
Like I said, this is you. This says, oh, that's a Stuart picture right there.
Oh, and then when you mix it with your red headlamp, it's great. We have Technicolor Stew, and I'm happy.
Oh, we kid because we love Stuart. All right, we're going to move to Gary, and I think I see is this the bubble?
It certainly is.
Nice.
And down here at the bottom corner is M52.
Oh,
That's
okay.
amazing.
Yeah.
And with this one, I can zoom in a little bit.
Oh, look at that.
That's amazing.
Look at that. That is. Now, it's somebody. Roy, you had a picture of. No, Gary, you got an old picture of the bubble that you did, right?
Yes.
But I'm sure, like, all of you have pictures of the bubble. You're now racing for your.
Well, of course.
So, this would be cool to see some everyone's sort of images of that they've done maybe when the moon wasn't destroying.
And this again is hydrogen alpha. Now this has only been 2x2. The others I've been binning 4x4, so that I could zoom in a little bit and get some detail. And it's again a 2-minute exposure. So it's
That's
live,
fantastic. Folks. Yeah, that is fantastic.
And so again,
you really see what's going on there. So what is it?
What is it? The bubble shape here. It's very hot star in the middle of this hydrogen region, and so the pressure from the radiation has kind of carved out this spherical region inside of the gas there. So you have kind of a void, and on the edges of it, it's kind of like a snowplow kind of effect from the radiation pushing things out, and so the gas is built up a little bit to show us this nice bubble structure at around this very bright hot star.
So I got a question on the trackings for you, Phil. What direction is the Milky Way spinning? What star constellation is leading the way? What is the front of the bus? And right now you're just a disembodied web page.
Oh yeah, I had. Oh, I see. There we go. I'm not sure I can answer that question because we're part of it. It's like asking direction.
That's why I threw this one at you.
Yeah.
What's the front of a plate?
It's like being in New York City and asking which way people are walking, and it's like, well, everybody's walking, maybe in one direction, but I'm walking towards them, and there's all these different velocities added together. And I think the sun is going around the Milky Way in the direction towards like Hercules or Lyra, which is up right now in the late summer sky, in the fall sky. But I mean, the Milky Way is just a big mess. It's like you know what it's like. It's like this. Oh yeah, got my old DVD Milky Way thing, right? And so the whole thing is spinning, and we're in here someplace going around as well. And so the sun is sort of heading in one direction, and all the stars are in the sky are moving around. Unless you mean what direction the Milky Way itself is headed. I believe it's being pulled towards the Virgo cluster, which is another cluster of galaxies about 50 or 60 million light years away.
But I guess it's still all relative, right? I mean,
is there up in space?
I remember a friend of mine a few years ago wanted to know, how far the Earth moves in a certain amount of time, and I thought, well, what do you mean, right? Because the Earth is spinning, and it's going around the sun, and the sun is going around the Milky Way, and the Milky Way is headed off towards some other, galaxy. And we talked about it for a couple of emails, and then we forgot about it. I just basically we dropped it, and then he wound up talking to somebody else who basically just calculated this in a very simple way. And I was saying, look, these are all pointing in different directions. If you want to figure out what your total velocity is in one direction, that's complicated. He simplified it way down and wrote a website called "Did the Earth Move for You?" Because if you wanted to know how, you could write in, you could sign up and say, here's the last time I made love, this is how long it took, and here's how far the Earth moved in that time. And it wound up getting like 1 million page views in a week or something like that. So it's a pretty funny idea, actually.
That sounds like the kind of thing you'd be good to do, like a YouTube video explainer when you can kind of
So more entertaining than summing vectors, then, right?
Yes, exactly. That's what I was thinking. And it's not even just vectors, right? Because they're instantaneous. You've got to know where you are in the Earth because the Earth is spinning.
Right.
So you're pointing this way. You're pointing this way. It adds and subtracts. Sorry to make this PG-13.
Paul Holt answered that quite nicely as well. He said, "What's the first horse in a carousel?" Which I thought was pretty great.
Oh, there you go.
Here we go. Okay, so here's a nice view from Gary. This is a older picture. This is one that he's processed. So
yes, this is taken in hydrogen alpha, oxygen 3, and sulfur 2, and I've mapped the hydrogen as green. So in this picture, sulfur is going to show up as red, which there isn't much, and oxygen is going to show up as blue.
But you can really see that bubble shape. It's just amazing.
I'm a little confused, actually. And what we've got here is a gas cloud, a molecular cloud. So you've got a dense, sort of dark clump of material. It's dust and gas and molecules like carbon monoxide and stuff like that. And it's got there are two stars going on here. One of them is lighting up that cloud. And I think that's the bright star you see just to the right of the arc of the bubble. There's another star, that one there, I think. But there's another star that's actually creating that bubble. You've got a young massive star. It's like 15 times the mass of the sun. And it's blowing off a wind like the solar wind that the sun has. It's much more dense and much more powerful. And that's what's carving, it's sort of pushing out on the material of that molecular cloud, kind of like when you got a snow plow and the snow builds up in your shovel. It's like that. So that stuff is also being pushed out by I believe a second star. There is a star to the right of that bright one, but it's not in the center of the bubble. So I'm not sure I understand exactly what I'm seeing.
So Roy, are you showing the bubble as well, or?
Yes.
Just another
That's
take
in, Gary's was in narrowband. This one is actually in RGB.
Wow.
Okay.
Yeah, I don't really get that.
Yeah.
It could be the stars off center.
You would see that central star, right?
Well, a lot of the times in objects like these, well, not
They're
like these, but in similar objects, the star is off-center. Sometimes because the star is moving really rapidly, and there was an event a long time ago that made it carve out this bubble, and in the meantime the star has moved. Sometimes you get a supernova. The star's in a binary. One of the stars blows up, and the other one goes flying off like a rock thrown out of a slingshot. There are a lot of different ways this can happen. But it sure, I mean, look at this picture. It sure looks like there's that bright star that's off-center. I wonder if that's it.
Here's one from Scott. This is from Wikipedia.
Wikipedia, yeah.
Scott is using the Wikipedia telescope tonight.
Yes, that's an awesome picture, Scott.
That's a great. Is this live, Scott?
It is live from my laptop.
From Wikipedia, coming to you live from Wikipedia.
Thank you, Creative Commons. I appreciate that.
And there's a bigger arc there too. It looks like a bigger bubble. Interesting.
So Scott, are there any? Sorry, any readings from, since you have the Wikipedia up, readings on the distance to the nebula, distance to the two stars that are in there?
You know, I'm seeing here that the main star, SAO 2575, we have the mass between 10 and 40 solar masses. So, but as far as the distances between them, not really. They're just showing that we have the stellar wind and the magnitudes going on there, but not as far as their distance going on.
Okay.
And so that start's going to go kablooey, isn't it?
Oh yeah. Yeah.
That's probably a Wolf-Rayet star. Anytime we don't know the mass of a star very accurately like that, like within a factor of 4, it's probably because the star is very active. It's blowing off stuff and all kinds of things are happening, and so it's really hard. These stellar models, these physical models we have of stars, we understand pretty well how stars behave when they're like the sun. And so you can look at a star through a telescope, compare it to the sun, and say this is 1.42 solar masses, 1.42 times the mass of the sun, up to a certain amount. And then when these stars start to get really big, they're so bright, they're so hot that they're blowing off winds, and they're undergoing all kinds of seizures and things, and it makes it very difficult to know what the mass is.
No, I really love how you can see the geometry of the balance of forces happening, and you know that at some point gravity, which we're always dealing with every day, and we can think, hey, spheres are happening. Well, it's just overpowering it, and you're just seeing this sloughing off going on through planetary nebulae and things like that. They're just showing up in bubbles. So the bubbles of space are just this imbalance of forces of awesomeness, and they look amazing, absolutely amazing.
And Gary's actually changed his picture on us.
Yep.
What now, Gary?
This is half of the California Nebula.
Oh, it's not new.
It's been a while since California's been up.
All right.
But this is, what I say, half of it. I can show you right here. Let me get my screen share. And
so is that the northern half? That looked like the Bay Area at the one end of it there.
Yeah. Come on. Is it?
Yeah, it's come up. Yeah, we see it.
Okay, so this is the purple box is my field of view, and this is about what we're looking at. So I'm just a little bit over half of the total nebula in that picture.
And there's a nice view from Stellarium, sort of showing what he's seeing. So that's great. It's really nice features, considering how awful the seeing is tonight.
Yeah, it's a pretty good exposure to pick that up. I don't think this is ever a naked eye object. It's maybe under some really good conditions, but this tends to be one that's going to show up much better in photographs than it ever will to a naked eye.
But this is one of those things that it's perfect for hydrogen alpha, right?
Oh yes.
Oh yeah, when you don't bin this one and you get a lot of sub exposures, there's the detail in this just seems so, it's like dust. It's just
That's
so
what it
fine.
is.
Yeah, I know, but it's just in the photo you can look at it and see it. It looks just like powder.
Yeah, and
Wow.
and that is 2 minute in a bin 4x4.
Wow.
Fantastic.
I think I always want to stretch the pareidolia on these like way too far, but to me, I mean, it's that little black spot at the bottom that I guess, to me that's like the Bay Area. Then the much brighter areas along the one side is more like the Sierra Nevada, and you've got all these very high peaks in that portion of California. So again, I always stretch this too far with these emission nebulae, but that's how I'm seeing it.
I'm going to move on to
good to me.
Mike's image.
Yeah, you get the Crescent Nebula there. Speaking of Wolf-Rayet stars, I think this is a great example of it. I think I had put up a color version of this on Google Plus this week. In the bright center there is the star that, and Thad can fill in here the huge gaps I'm about to leave, fill there that there was a star that's very dense and throwing off a huge shell of gas. So this is about a 3-minute shot of it. And just as you were talking about, or Gary was talking about that wonderful dust in space, you can see, at least on my monitor, hopefully it comes across over the web there, kind of that faint, almost misty look in the background to this. This is part, someone has a wild field view of it, or wide field view, a really huge cloud of dust.
So yeah, I mean, this is in the thick of the Milky Way. This is pretty near the star at the center of the Northern Cross, or the heart of the Swan. So there's a lot of hydrogen in the background in this part of the sky. And so yeah, again, a star that is so massive that, I mean, our sun has solar wind, but when you get particles that are constantly ejected from it and flooding out into the solar system, if they get caught in Earth's magnetic field and dragged into the atmosphere, they make aurorae. This is in a case of extreme solar wind, and so you can even kind of see how the ripples of it are kind of blowing off from the star and forming this pattern around it. So yeah, it's a Wolf-Rayet in the middle there. And that's going to go boom at some point. Maybe it already has. Maybe it will in the next 50,000 years, the next couple 100,000 years. But that star is doomed.
They do not live long.
Nope.
A few million years.
Few million.
Yeah.
Yep.
I always call this the mammogram nebula. When you see it in seriously, when you see it in high resolution, it looks just like the X-rays you see from that. But interestingly, I'm looking at this now, and I love speculating about this, but I used to do this for a living. The star is off center again. It's up a little high, and I'm wondering. And if you look at the nebula, it's squashed. Now that could mean it's that the star is spinning rapidly. It could mean that there's another star orbiting it, and they're spinning around really rapidly. And so when it blows off gas, it blows it off preferentially, flattened like that. Or it could be that, as you said, it's in Cygnus, so it's in a region where there's a lot of
You lost your image there, Mike.
It lost me.
No,
it
there
could
it is.
be
We're
that
back.
it's moving through space rapidly, and when it blew this thing off, some sort of episodic event where it just went boof, and the stuff expanded, that stuff is ramming into that medium and compressing a little bit. In the meantime, the star is still moving, even though this stuff is slowed down, and that makes the star off center. That does happen. I've posted a few pictures of gas clouds like this, where the star is way off center and the gas cloud's oddly shaped. And that's usually because the gas itself is being compressed and slowing down. The star, that was like a cannonball, it's just ramming right through that stuff, and it gets off center. It's amazing what you can speculate about, right? What you can think about when you just by looking at a picture and knowing a little bit about how these things go. But then you can always test that hypothesis. It could be totally wrong, but in a lot of times it's right.
Now, I've got a question from Chris Dutka on Google+. When will ISON be available? And this is, of course, Comet ISON, which we all freaked out about 2 months ago, which is that it could be the brightest comet in living memory when it passes by the sun. But right now it's pretty faint, and so not really that useful to look at in any of our telescopes. Did we do ISON? No, we didn't do ISON. We did one of the other comets.
Bergenrother.
Bergenrother.
I tried to image it tonight, but it's getting too dim.
Yeah.
I tried a couple shots tonight, just wasn't working.
And so we're not going to see it until it does its flyby of the sun, and then hopefully will brighten up significantly. I think if either it's going to get shredded and gobbled up by the sun, but if we're lucky, it'll brighten up significantly and become. Someone was saying, what's the estimates, Phil? You've been reporting on this too, right? Like several times the brightness of the moon.
I haven't.
Which I know you haven't written about it.
No.
Oh, okay.
For me, I remember Kahutek, and a lot of comets. They're unpredictable, and just because it's bright now doesn't mean anything. This thing could completely fizzle away. It could disintegrate. A lot of bright comets are bright because they're breaking up. I don't think this one is, but I'm just saying this happens sometimes. Mm-hmm. And then by the time they get near the Earth, it's gone. Other times they just don't behave the way you expect. Now, if you just sort of take the distance to this thing and calculate how much brighter it'll be when it gets near the Earth, yeah, people are saying it's going to be like the full moon. But I don't trust those estimates. So for me, it's a wait and see sort of a thing. And it goes the other way too. A couple of years ago, there was a comet that was just nothing. It was a dud, Comet Holmes, and it was on its way out. It was out past the orbit of Mars, and then it suddenly flared. It got really bright. Yeah. And it had this huge expanding cloud of dust around it that got so big. Now, mind you, this thing was farther away than Mars at that point, or it was tens of millions of kilometers away. It was visible naked eye. You could see the disk of this thing. I saw it myself, and I could see that it wasn't starlight. It turns out the comet hit something, a small asteroid or something banged into it, and created this huge expanding dust cloud around it. So, comets are fundamentally unpredictable in specific cases. So, in my opinion, we'll wait and see. It's exciting, but, we'll see.
Yeah, I think, of course, it's really unpredictable, and it all just depends on on what the comet's made out of. At the same time, though, the chance to see a bright visible object, like was it Hakatake was the last one that was just a really phenomenal comet, and we missed the one that was only visible to the folks in Australia this year. So,
Lovejoy.
Yeah.
The pictures of Lovejoy from space.
Yeah,
so
I know. So I mean, I now know. Like I didn't realize, but like Hale Bopp and Yakutake, like what was that? 10 years ago, 15 years ago?
96 and 97. Yakutake was 96 and Hale Bopp was 97.
Yeah, they were right after each other. Both
really special. I didn't realize how special those two comets were, and we haven't had anything like them since. So if Ison even stands a chance of really brightening up, I think it's going to be pretty exciting. So that'll be next year, late next year. So
yeah, late November.
Yeah. So like this time next year, or like another month from now next year, we'll know if it's going to be the brightest comet of 400 years, which is the possibility. So don't count it out, don't rule it out.
But
also,
right now,
don't count on it.
Right. Right now it's like magnitude 14 or 15, and it's just not worth looking at. Hergenrother was the same kind of deal, though, that where it is, its perihelion only brings it as close as about Mars's orbit, so it never gets very close to the sun. But there were closer images of it, better images of it this week, showing that it is breaking up. And so because of the split that occurred in the comet that always releases a lot of material, and so it suddenly jumped by 6 magnitudes in brightness, more than 100 times in brightness, which is the only reason we were looking at it at all in the virtual star parties the last couple of weeks. Otherwise it'd be like, well, there's a comet in that field of view somewhere, but who cares? It's a little dot. So
Well, I think we're sort of closing in on the hour, so I think we'll probably wrap things up. So I want to sort of send out good vibes to all of the folks on the East Coast and all of our East Coast astronomers. I hope their telescopes don't blow away in this horrible storm. And I want to thank everybody who joined us watching live tonight, and everyone who's watching this after the fact. I really appreciate you taking your time. I know you could be watching Walking Dead right now, but instead you're joining us here. So, so got one last view from Gary here. Is that the rest of the California nebula?
That's the southern end of the California. Here's the Bay Area up in here. That's only a 1-minute exposure.
Wow, that's great. Well, and so a big thanks to Gary Gonella and to Mike Chasin and to Roy Salisbury and to Stuart Foreman for braving the I guess in some cases they're living rooms, in other cases outside in the cold. Actually, Stuart's the one who actually goes outside and actually manages his telescope outside. So
Yeah.
We have a bunch of pampered astronomers here, don't
we?
we?
They really are. They really are.
I have to lug mine up a hill, man.
Both ways?
Both ways. By the way,
the
Thad, it's
snow.
4-3 Giants in extra innings. They just scored.
Okay. Thanks, Stuart.
Why would you do that to me, man? That's horrible.
And thanks to Scott and to Thad and to Phil Plate for joining us at the last minute and participating in the conversation. Really appreciate it. It was great to see you again here, Phil. So thanks everybody. We'll be here again next week. And as always, so I just want to remind the astronomers and anyone who's watching this, feel free to post all your pictures into the event, so that you can actually see the cool pictures that were taken during the event. It's great because what's cool is everyone who attends the event gets an email from it, and they can see all the pictures that were taken, and they can reminisce about the wonderful star party evening that was had the night before. So, and if you can even, by all means, feel free, if you're watching this and you've taken pictures, throw in your own space, your astrophotography into that event as well. It'd be great. So, all right. We'll see you all next week. Thank you very much.
Have a
Good night.
Good night,
Ending the
everybody.
Bye, everyone.
broadcast.
Have a good night.